Hello everyone, welcome to BYJU'S exam prep. So I'm here with a small trick of signals and systems to calculate the circular convolution. So if you have a two discrete time sequence of finite duration and if you want to calculate the circular convolution of those two symbols sequence, then you can use this trick. Okay, so before going into that, I am also discussing one small property of circular convolution. Suppose you want to calculate the circular convolution that can be done in the discrete time domain, and if you suppose calculate the DFT, that is the discrete Fourier transform, then you can also calculate the circular convolution just by multiplying those two Fourier transform DFT. So if you want to convolve circular convolve the x of n, and let's calculate the DFT as xk and h of n and its DFT is h of k, then instead of calculating the circular convolution in the discrete time domain, you can calculate by multiplying also, and after multiplication you can take the inverse DFT. So that is the circular convolution property. Now let's understand the trick how to calculate the circular convolution by or in the time domain. Okay, so in the time domain, so for that let's take one example. Suppose this x of n is 1 2 2 1 and the second sequence which we want to convolve is this is 2 3 2 1. Okay, we generally represent the x of n and h of n in this square bracket form. Okay, now suppose you want to calculate the circular convolution, then just use the sum by column method. So circular convolution you want to calculate by sum and column method. So this is what you can do is simply write the x of n in this column like 1 2 2 1 and write the h of n in this row. This is 2 3 2 1. Okay, now just do the simple multiplication as we multiply the two numbers. It is like a multiplication of 1 2 2 1 with 2 3 2 1. Okay, so this one is multiplied with this, so we will get 2 3 2 1. This 2 will be multiplied, so this space is blank, and this 2 into 2 4, 2 into 3 is 6, 2 into 2 is 4, and then 2 into 2 into 1 is 2. So this 2 will move into this place. Okay, this 2 will move into the blank space. So this is the 2. Now the 2 space will be left blank. Okay, so this 2 is multiplied, so we will get 4. This 2 is multiplied, so we will get 6. And this 2 is multiplied, this will be 4 and this will be 2. Now these two will be placed in this space. So this is 4 and 2. So write in this form 4 and 2. So start writing from the left 4 and 2. Now leave the 3 space and we will multiply it again. So this is 2 3 2 1. So again this 3 2 1 should be placed here. This is 3 2 1. Now what you have to do, you have to just do the simple addition. Now forget about these extra terms because we have already moved into these places, so you don't need to worry about these extra terms. Now you have to just add these as a column. So 2 plus 2 4, 4 plus 4 8, 8 plus 3 11. So this is 4 plus 3 7, 7 plus 2 9, 9 plus 2 11, 4 plus 1 5, 5 6 5 11, 11 and 2 13, 6 plus 2 8, 8 plus 4 12, 12 plus 1 13. So you will get the convolution of these two is 11 11 13 and 13. Now the question may arise that if we have the 0 at this place and this place, then in the final result where will be the 0? So this one is having the 0, so this place where n was 0 and this is the place where n was 0. So where they two are multiplying, so these two are multiplying at this place, so that will be the place where n equal to 0 in the resultant, which is the convolution of x of n and h of n. Okay, so I hope that you have understood this concept, and this is the trick to calculate the circular convolution of finite duration sequence very quickly. And for the linear convolution, you just need to do the simple multiplication. Like you don't need to fill this space, you have to just multiply and add them as a column wise. You will get the linear convolution by the same method. Okay, so thank you for watching this session. Don't forget to subscribe this. I will come with another trick of like communication or signals system in the next Trickopedia session. Thank you.